Jai Mahakal and welcome to Docker Yatra. We are going to learn Docker from A to Z, and if you have prior experience of Docker, then you can jump to the various timestamps which are created. And here is the basic TLDR of what we are covering. We are in the first chapter. We are going to cover basic understanding of what the problem statement is, what is Docker, what are images and container, what are there, and what is the basic difference. What is the concept of layers in images, and we have some part of operating system where what are the basic levels of operating system and where does exactly Docker fits in and how is it different from a virtual machine. We'll then get comfortable with Docker while playing with it, and we'll also understand how port mapping works. Then on to the second chapter, we'll walk through some basic Docker commands. Then we'll also understand how Docker networks work, how to create volumes, what is Docker Compose, what is the problem that it solves. Then we'll also see how we can create images with Dockerfile and work with Amazon ECR. And finally, we'll understand the contribution of Docker in open source. So before starting the video, I have a quick message for you and then we'll get started.
Zico Cloud. Zico Cloud is a global communication service provider which provides developer-friendly and powerful SDK APIs to build many communication features such as video call, chat, video conference, and live streaming. Zico Cloud also offers UI kit to build video call apps in low code, and it has a lot of features. So if we talk about the features, it has one-on-one calls, group calls, video conference, live streaming, live audio room, and in-app chat. You can register at Zico, click 10,000 free minutes. The steps are really very simple. You just have to hit sign up, your name, last name. You can select your country and you can enter your email. Okay, you can get the verification code. You can also verify the stuffs. So you will get a email verification link. So you can check your mail. You can set up a very strong password. Once you land, you'll see a dialog box which will ask for some of your details. So you can provide the details, and maybe you can give this a little detail, your mobile number, and you can hit enter and you can go to the dashboard. As you can see that I have already received 10,000 free minutes, and this is my balance overview, and the overall dashboard is really very cool and really very easy. And you can see list of all your projects, stats, billing, and package. So overall, Zico Cloud is really a one-stop solution for all video and chatting features for your projects. Let's come back to the video.
Okay, so let's get started with Docker. And before understanding Docker, let us first try to understand the use case as to why Docker was created and why exactly do we need this. So imagine there is a company and they have a Next.js application. That Next.js application has certain constraints. For example, it works only on Node.js 18 point some version. For database, let's say they use Postgres and they are constrained to specific version of this Postgres, PXX. And then they have Redis for caching, and again some version constraints are there, and so on. The list is endless. Now you join this company as a developer, and somehow due to lack of documentation they forgot mentioning key we have to run this application on Node.js. This should be the Postgres version, this should be the Redis, and unknown you start setting up all these locally. And let's say instead of Node.js version 18 you set up 20, instead of Postgres 1 you install 2 and Redis 3 and so on, and you eventually realize the application is not working. So here the problem is that the exact replication of the environment. Okay, so this whole box is a environment of our application, and each developer is facing difficulty in setting up this exact environment on their local. Okay, because they have constraints on the versions. So Node.js, Postgres, Redis, and so on. So this makes the developer life a little tough, and it is not very easy to have an exact developer environment across all local machines for all developers. So someone thought, okay, now instead of doing this every time locally, why don't I put everything inside a box? Okay, so example, this is a box, and that box will contain exact specification of the applications that are required to run the application. So that box has Node.js 18, Postgres XX, and Redis XXXX. And all the developer has to do is put this box in their machine. For example, this is my Windows machine. So I just have to put this box in my machine, run some commands, and it is up to this box to manage all the configurations, and it will have the server running automatically. So now I don't have to worry about setting up Node.js, Postgres, and Redis, and so on. So this is what Docker is. So it is difficult to replicate the system configurations, be it on Windows, Mac, or Ubuntu, and the installation process is also different. Okay, for example, to install Node on Windows is completely different than installing it on Linux machines. Same goes for Postgres and Redis and so on. So let me put the exact definition of Docker. So if I read it correctly, so with Docker, you get your own isolated environment that has packaged all configuration. So this is the exact definition of Docker, and that is all you have to know. So imagine this box is Docker that has packaged all the configuration that is required to run this application. Okay, so this is what Docker is. Now inside Docker, you have a concept of image and containers. So let us discuss what it is and see how we can improve our understanding of Docker. So let's talk about images. So images are the artifacts, okay, or you can say code that you download from repository. So what is exactly is repository over here? So if you go to Docker Hub over here, and if you open this, so this is the repository of Docker. What happens over here is, okay, it's not loading. Let me refresh it once. Yep. So over here, this is your Docker repository. What exactly happens is, for example, if you want to Dockerize Postgres, okay, so there is a official Postgres image that is available on Docker, and this image is on a repository. You have to download this image from the repository and you can run this. What it contains is like installing Postgres from their official website, like Postgres download Windows. If you go do this, so you will head over to the Postgres website. Over here, now they have different versions for Windows, and then you can start downloading it. But instead of doing this process, instead of downloading it on your machine, you can download this on your Docker system. Okay, so whatever you download from this Docker Hub or any private repository. So there are two concepts. One is Docker Hub, which contains public images. Okay, so like any software which you download available online has a Docker image for itself. If you do not wish to download Node.js, then you have a Node.js also there. Maybe not this. This is Selenium. Let's come back over here. So if I search for Node, see, this is a Node.js container. So instead of manually installing Node.js on your machine, you can have a Node image running. Okay, and you can maintain different versions of Node.js as well, and same goes for Postgres as well. So this is what image is. Okay, whatever you download from a repository is a image. There are two type of repository. One is publicly available on Docker Hub, and one is ECR, Amazon Elastic Container Registry, where you can host repositories that you and your employees in your organization can have access to, just like GitHub. Okay, so there are some repositories and there are some private GitHub repositories. Same goes for Docker. So Hub is your public repository, and Amazon ECR is your private one, which you and your employees can have access to. So which means that you can also create images. Okay, so there is a concept of creating images as well, which we will discuss later. But for now, we understood that there are two types of repositories, public and private. On public, we can find any software which we can run on the Dockerized system. Okay, that is what it is. Then we have something called as container. So we have images and we have containers. Okay, so it's really very simple. I don't know why people create confusion between these. So images is what you download, and once you run that image, it becomes a container. It is just a jargon. Okay, nothing fancy. So whatever you download, okay, for example, if I downloaded this node image by this command docker pull node, I downloaded the image. Now once I run this image, once I run the node inside this image, it becomes my container. That is as it is. Okay, this is how simple it is, nothing fancy. So we understood why do we need Docker and what are images and containers. Okay, so if we check Node.js, we check for Node.js image, we checked for Postgres image. Okay, we check for Postgres. Okay, so we have Postgres. Do we have Redis? So we have a Redis image also. So you can see that every piece of software that is needed to run our application has a public image on Docker Hub. Okay, so we will see in future how we can pull these images into a single package, and we can run our Next.js application from that packaged image. Okay, we will see that in a moment later in the video, but for now you understood why do we need this thing and what are images and containers. Now I'm going to make a statement, listen it very carefully. So Docker is a kind of operating system environment that helps you run applications. Okay, so does it make sense? Yeah, exactly, because I can have multiple softwares. I can pull Node.js, I can pull Postgres, I can pull Redis on something. Okay, that something is called here operating system. And on that some operating system, I can run these applications and they can interact with each other and do some stuff and help me build a Next.js application. So does it means that is Docker a complete operating system? Is it like a Windows? Is it like Ubuntu or what? So we do have images of operating systems as well. So if I search for Alpine, okay, so Alpine is a Ubuntu image. Okay, a minimal Docker image based on Alpine Linux with a complete package index of only 5 MB. Okay, it is the smallest version of Linux which you can use. So, and so you can see that, okay, so this is a Linux image. Understood? Makes sense. Now, if I open a Node.js image, and inside this image, where is the Dockerfile? Just wait a second. Okay, so these are the Dockerfile links. So if I open this thing, you can see that this node image was again created from a Alpine system, from a, okay, I know you don't know this file. Okay, I haven't taught you yet what a Docker file is, but I'm just trying to establish a relation that this Node.js image sits on top of a Linux image. Okay, so here a Docker image is made up of various images itself. So if I say that I am running a Node.js image, this Node.js image sits on a Alpine image. And if we go back and see what the Alpine image is made of, I haven't explored this yet, but we can check. So let us say that I want to use Alpine 3. So it is made from scratch. Okay, it is made from scratch. So below this, scratch, there is nothing. So this is a root. Okay, from scratch, you created a Alpine. Alpine, if you get confused, it is a Linux operating system. And on top of that, we have Node. Okay, and now on top of Node, I can create a new image. Okay, for example, I created my own Node.js application. So I can say that I can create my Node.js application on top of this Node image. Makes sense? So I can add one more, layers of images. So there are layers of images. Okay, that is one concept. Now, if I say that, not talking about operating system, okay, I made one statement that it is a kind of operating system environment given to you. Is it true? Yeah, because we just saw that our Node.js was already running a Alpine Linux operating system below it. Okay, and it is running on top of it. Okay, we understood this. Now let us try to understand that how Docker is different from a virtual machine. So it truly resembles like it is a virtual machine, but there is a slight difference. Okay, we can go into that complexity of this whole Docker. So an operating system is made up of three components, three layers. One is a application layer, and one is your operating system kernel. These things I think you have already been taught in 12th standard or in first year of college. So these are some basic stuff, and you have your hardware. Okay, this is what your basic machine looks like. So this is your application. Application can be, you can playing GTA 5, GTA 6, not released yet, and any application you are running. Then you have your operating system kernel, which interacts with hardware. For example, you have application, a Zoom, for example, the Zoom Meet clone, which Google Meet clone, which we made. Okay, so on that I had certain APIs which opened the camera of my machine. Okay, so I had to interact with hardware at certain level. So how that was done? So I have written some code in JavaScript that can trigger some commands on the operating system kernel, and that operating system kernel indeed interacts and opens up my camera. So if we talk about what exactly is a virtual machine, so virtual machine only virtualizes the first two steps. So I can say virtualized. Okay, the first two steps are virtualized, and it uses your hardware to achieve or do task. Okay, that was stuff. This was virtual machines. Then what is a Docker? Okay, where's Docker sits in? Docker only virtualizes your application layer. Okay, so let me type virtualized. So Docker only virtualizes your, let me put this over here, Docker only virtualizes your application layer. Okay, so it still uses your system's OS kernel, yours hardware. It's just that it says, okay, instead of directly installing Postgres on your machine, I will create my own virtual environment. Okay, and on that virtual environment, I will run that Postgres, but behind the scenes, I am going to use yours kernel and yours hardware only. Okay, that is why Docker images are lesser in size as compared to virtual machines. Okay, that is what you have to take from this particular chapter of this tutorial. Okay, so this is what a virtual machine and a Docker is, and this is a slight difference between them. All right, so we have understood why did we need, what are images and containers, what are layers in images, and how exactly the Docker virtualizes and at what extent it is different from a virtual machine. So we have set up the basic grounds to understand Docker. We are also saw what is a Docker private repository, public repository, and we also saw this ECR, and we explored key what is a base root from which a Docker is created. So it can be created from scratch, and then we keep on adding layers on top of each other. Okay, and hence it is proved that there's a concept of layer in Docker. You can talking about the installation process. Okay, so you can it depends again on your machine only, if you are on Linux, if you are on MacBook, or if you are if you are Ubuntu MacBook, or if you are on Windows. So if I say Docker install Windows, so it will give you some steps to install the Windows. You can follow this documentation. I'm not going to cover how exactly you can install this and other stuffs. And there is one thing that if you are, once you have done with installation and everything, and let's say you want to use Postgres, okay, you want to use Postgres for your application. Okay, make sure that you do not have installed Postgres locally on the application layer of your system. Okay, key, you don't have a Postgres locally, otherwise your kernel will get confused whether I have to take Postgres from application layer or from the virtualized layer. Okay, so if you go to control panel and install a program, and you can search for that, you don't have a Postgres SQL. So I don't think this is something else. Okay, I had already installed it. This is, I think, some dummy image. This is development group, not exactly a Postgres. So you can consider that it is not on my system. So make sure that you don't have a Postgres installed on your system first. Okay, and you only install Postgres directly from the images of Docker. So once you install it, you have this Docker application, Docker desktop. Let me open this for you. So you can see that this is your application for Docker. Here you have containers. Here you have list of all the images. Then you have volumes, and you can see that this Prisma DB data was created by me some time ago. But yeah, anyways, then you have builds, you have them environments, and so on. But primarily we'll be having focus around containers and images. Okay. So I had installed these guys a couple of time back. So let me delete them so that we can start fresh. All right. And you can open a terminal. I am using Windows PowerShell. So if you type Docker, you may get this. Okay. So if you are seeing this, which means that Docker is already installed on your system, and you don't have Postgres and other things installed beforehand. Okay, so now once we are done with this, let us try to understand some basic Docker commands. Okay, so we are in the next chapter of this tutorial where we are understanding basic Docker commands that we use in daily life. Okay, so first of all, we can see this. Let's go back to Postgres. So I want to install Postgres on my machine. So I will just copy this command. It says docker Postgres, and I just have to paste this. Let me zoom this a little for you. I hope this is visible. So docker pull Postgres. If I hit enter, so it says that I am going to pull the latest Postgres for my system, and these are the various layers that it is downloading. Okay, so make sure you have a speedy internet. It takes time sometimes. Okay, so I have installed Postgres. All right, so this was the first command for the tutorial, which is docker pull. So docker pull and the image name. Okay, so this is the name of the image, and I installed it. Now if I go over to my images, you can see that I have a Postgres image which has a tag of latest installed on my system. And let's go back, not needed. And status, it is not used, created 9 days ago, because I had already installed once Postgres 9 days ago before creating this tutorial. Okay, and this is the size, and I can run this image and so on. But wait, hold on, there is something other concept that you can install a specific version of Postgres. Okay, so right now we installed the latest version of Postgres. What if, okay, as per this scenario, what if like my application has dependency on certain Postgres version? For example, I want 16.4. Okay, for example, I want 16.4. Okay, how do we do this? It is very simple. You head over to terminal, pull this command docker pull Postgres, and add a colon and say type your version. Okay, so it is 16.4, so my tag would be 16.4. Hit enter. It will now say that yep, so what happened? Okay, it installed, and here you can see that docker pull 16.4 pulling from library Postgres. And since layers were already cached, so it didn't took much time for me. Okay, so if I head over now to my images, I have two versions of Postgres already installed on my system. So I have 16.4, I have latest version as well, and both roughly taking the same sizes. Okay, so I have two images. Now I can run these images on my system. So to run the image, firstly you need to fetch the ID of the image. So if I say docker images, it will give you all the images that you have on your system. So we have Postgres 16.4, Postgres latest, these are the tags, and this is the image ID. So if I say docker run and I paste this image, so it says database is uninitialized and super user password is not specified. You must, okay, so these are the various issues that we have right now. We can take another example of Redis just for clarity. Okay, and I'll then deep dive into why this was not working. So let me fetch a Redis image. Okay, so we have docker pull Redis, and let us do docker pull 6.2 as well. Okay, so docker pull Redis 6.2. Tick. Now let's clear this and run Docker images. You can see that we have 4 images. One, we have 2 of Docker. We have 6.2 and latest. Now if I just copy this and say Docker run and I paste this ID, it started running this particular Docker image, that is latest. Okay. Now in another tab, okay, I again do Docker images, and this time I want to run Redis 6.2. So I will grab this and I say Docker run this, and it started. So you can see that currently I am running 2 Redis images on my system. Okay, one is this image of Redis latest, and another is Redis 6.2. So as I have said before, that once you run image, it becomes container. Okay, so this means that we might be having 2 containers running. Okay, let us verify. So these are the 4 images, and if I head over to container, I can see I started to run this Docker container, but it did not happen. But I see 2 running containers. Okay, this was a failed container for Postgres. Ignore this. But these 2 are the 2 running images which we are seeing. Okay, so these is the CPU utilization, and I start how much time ago I started these images. Okay, so now these are containers. Do we see more information? Let me extend this. No, the port and other information, I think it is not showing. Okay, so these are the logs. Okay, so Reddit started this, Redis version 7.4, PID this, and this is the port. Okay, now here, okay, here is the interesting thing, that I have a Redis image running on port 6379. Okay, it was happy image. Then this was a youthful image. This is also running on 6379. Strange. This means that these 2 should not be possible. Okay, these should have been conflicted, but no. As I said before, that containers are isolated environment, which means that this container is isolated from this container. These 2 are isolated. Okay, they do not interact with each other or have any sort of dependency. So this created another Linux environment, this created another Linux environment, and so on. Okay, I hope you understood it. So these 2 are running on these port. Okay, now here comes the problem. I'll tell you why. So these are the 2 containers, 2 containers running, 2 images running, which means containers. Okay, so I'll call them containers now. These are the 2 containers running, and we can see the list of all the containers running using this command docker ps. Okay, now there is very interesting thing I want to show you. So this is the container ID. This was the image ID from which the container is created. This was the command, we can ignore this. And this was the name. This is the name of the container, youthful and happy. And these are the ports. Okay, these ports, so by default Redis runs on port 6379. Okay, that is why they have created this port 6379. But here let us say I am working in a service based company. I have 2 projects. And in one project I have to use this version of Redis. In another project I have to use this version of Redis, but I have to keep both of them running, but they are having single port 6379. Now how would I know that I can connect to this port, I can connect to this port. Both are the same port. How would I know कि I can connect my application to this particular running Redis or to this particular running Redis? How can we do this? So here there is a very interesting concept of ports. Okay, port mapping. So let me copy this, paste this here, and let me we are going to understand port mapping. Okay. So over here, so let us take two blocks. One is this and another is this. Okay, so we have two blocks. This, let's call this as Redis latest, and this one is Redis old. Okay, for just for clarity. So this was 7.4 and this was 6.2. So let us call this Redis 6.2. These all are running on the port 6379. So 6379 over here, 6379 over here. Okay, and now let me say that these are the containers. Okay, and inside that container there is an open port of 6379. Now we have these are isolated environments. Okay, so in these we have running Redis latest, in this we have running 6.2. now we have our local machine. Okay, we have our local machine. We have this local machine. Let us call this localhost. Now inside this localhost, what happens is that we have many ports available on our systems. Okay, ports can be something like 6000, 6001, 6002 and so on. Any port we can use. Now I say that I have a Next.js application running on my localhost. Okay, I have a Next.js application running on my localhost. I have two Next.js applications. Okay, Next.js 1 and Next.js 2. I have two applications running on my localhost. What I do is I map, let me grab the arrows. I create two mappings of the port. Okay, I can create two mappings of the port like this. This one is 6000 and this one is 6001. Now understand what is happening over here. So what happened is on my localhost, okay, I have Next.js 1 application running. So I can say that on my localhost, I want my 6000 port to map to this particular container of port 6379, and I want to map my 6001 port of localhost to map to 6379 of this particular container. Okay, so my Next.js app 1 can have a Redis running on port number 6000. Okay, and my 6001 will be utilized by Next.js application number 2. So this way I have two Next.js application runnings, two different images of Redis, two different versions of Redis without having to set up any Redis on my local environment. Both are isolated and they will not interfere with each other, and I can map 6000, 6001 to different containers of Redis. So how this is achievable? So first of all, let us kill all the servers. Okay, all the containers that we had running. And now if you do docker ps, no container is running at all. There is another command called docker ps -a. Here you can see all the containers that are running or that are not running. Okay, so here are all the 4 containers that we have on the machine that are currently not running. So these are all the list. Anyways, so coming back to port mapping, what we have to do is, first of all, you have a list of all the images. Okay, so these are the images. Now you have to say docker run -p, and then you have to provide the port on your host machine, which is your local machine. So I would say that I want to run one image on port 6000, and I want to map this 6000 to 6379 of the container. And then followed by this, you provide the image ID. Okay, like this. Let me put this again. Me 6000 6379, and then I paste it. Okay, now let's run this. Okay, and this is running, so we'll clear these two previous terminals. And I now if I run docker ps, you can see that the this particular image DAE, which was the Redis latest, is mapped to port localhost 6000. Okay, here you can see the mapping. Similarly, I can create copy this. Okay, I can copy this, and over here do docker run -p 6001 6379, and I paste the name of the image. I run this. Okay, so we have two images running. Okay, two containers running over here. Now if I do docker ps again, I can see that I have two Redis containers. One is mapped to port 6000, and the new one which just run up is on 6001, both pointing to 6379 on different containers. Right, now the name has also changed. Okay, this is tender something else, some name is given. Anyways, so that was the point. Okay, so this is what port mapping is. Now coming back to the thing, so I have 6000 6001 pointing to two different images, and my NXJS applications can connect differently to different Redis images. So that is what the power of networking is. So in the previous chapter we went through some basics, and now I think it's a good time to run through all the basic all the commands that you are going to need to understand Docker. So the first one was, we have already seen, was docker pull. So if I say docker pull node, this is going to pull a node.js for us, layer by layer. And let's run this in parallel and don't wait for it. The next one was docker run. Okay, docker run Redis. What this command does is it runs your image on a container, and if for some reason this image is not downloaded on your system, it will first download this and then it will run the image. Okay, so this was the docker run command. Then we have docker ps. This is going to show you a list of all the containers. Then we have docker ps -a. This shows all containers, be it running or not running. Then there was command that is very important, is that running images or containers in detached mode. So if I say docker run Redis, this is going to stop my container from executing any more commands. If I run this in detached mode -d, this is just going to give me a ID, and the container is already running. So if I run docker ps again, I can see this Redis is again running. And to stop this container, we have docker stop, and I just have to put this, and this is going to be stopped. Now if I do docker ps again, I can see no container running. So this was a detached mode where you can free up your terminal and execute any more commands. Then we have docker start as well. Docker start is a really cool command. For example, if you remember, we added port binding to some container. I think it was a youthful container before. So if you grab the container ID, and if I want to replicate the same port mapping again, if I have to run this container again with the same mode port mapping, will it be wise if I run docker run -p, then again I put the image name? No, right? We have already created the container before. I can just say docker start and put the ID, and it will run the docker container for me in obviously in detached mode. And if I see docker ps again, I can see that it already has the port binding. So docker start remembers all the configurations of the container, and it starts for you automatically. So you can leverage this docker start command. Then we have already seen the port bindings stuff already done. We have something called as docker network, which I'll show you later, where we have php mypgadmin and postgres connected on the same network. I'll show that in the later in the last part of this chapter. Then we have docker images command. We can see a list of all the images, and if you want to delete any image, it is docker rmi and image id. So image id, for example, I want to install node, and I put this, it is going to delete it. The only catch here is that this image should not be running in any container, otherwise it will fail for you. Okay, so that was the thing. We have already done port binding. And yeah, so let's talk about debugging the dockers. Okay, how exactly we can debug containers. So do we have docker any container running? Yes, we have a container running already. Okay, so let us first stop this docker stop, and let me paste this id over here. Okay, and what we can do is we can get rid of all the containers. Okay, we don't need them now. Okay, just for the clarity, and we have these images, that is fine. What I wanted to show you was, so if I say docker pull node, or maybe, okay, let us first see the command for the docker logs. How can we see the logs of the docker? So if I go back and run a new command, let's say for this. Okay, so okay, not like this, this will again stop. If I run this in detached mode, okay, like this, okay, I run a container in detached mode, and if I see docker ps, this is it. Now if I want to see all the logs, okay, although you can already see the logs of the container over here, if you click this, you see the logs. But if you want to see this on the terminal, you grab the container id, if you say docker logs and you paste it, you can see all the logs over here. So we can see all the logs. Now if I now pull a docker image of node.js, okay, so if I say docker pull node, this is going to install the node.js for me. It is going to take a significant amount of time, so let's just quickly fast forward it. So we have the node image installed on our system, and now if I want to create a container of this image, so I have to run docker run in a detached mode, and I have to add an interactive so that the container is not destroyed. This is just for Node.js, because as soon as you run D, you exit it out as well. So I want to keep it interactive, so it keeps on running and doesn't exits. And now here I can give the name of the container, because uh, Docker has a habit of giving random names to the containers, so it is difficult for us to know as to which container ID the container is pointing to. So we can give it a name as like Node.js container, and followed by the image that we want to create the container from. So we have this ID, and let me paste this. Now once I hit this, you can see if I do docker ps, I can see my container running, and this time the the name of the container is as per our needs. Okay. Now like I can do docker stop node.js cont. Okay, now it is stopped. Now if I do docker ps again, so it is gone. So instead of using IDs every time of the containers, you can create meaningful names of the docker and you can use them. So let me rerun the app. So node docker start node.js container, it will start it. And if I do docker ps again, it will see, we can see the container running. Now here the interesting part is that like I can see the logs. So I can do docker logs node.js cont, and it will give you all the logs that were printed. And if you want to dive into the terminal of the system, so it would be docker exec minus it stands for interactive, and node.js cont. And I think I did something wrong. Wait. Okay, sorry. uh, there was the first command, and I want to type into slash bin slash bash, and I am here now. If I do console.log, hey, hit enter. Okay. Okay, so I am into the system. Now if I type node, yeah, so now I am inside node. Now if I do console.log, hey, and this will print hey. And I can do command C, and I can do exit. What just happened? Let's rewind again. This was little difficult. So I did docker exec minus it. It stands for interactive, and then I want to go inside this particular container. Bin slash bash means the directory where I want to enter. Okay. Once I do this, you are into the container in the inside the operating system environment. We have this all the files and systems, and inside, since this is a node environment, we have node.js installed. And you can also see my cursor also changed to root and some random id. This means that we have uh, moved into the terminal of the container. Now since node is already installed, if I do node, and I can see my node.js system pops up. And if I do console.log and do 31 plus 2 33 and so on, I can execute node.js commands over here. Okay. So if I do control C, I am able to exit once. Now if I write exit over here, I will exit from the terminal of the docker itself. So these were the exit commands, and we have already seen the logs. So if I check the logs of node.js count, this is the same as this because nothing new was done over here. And the last, so the two things remaining are Docker network and Docker volumes. So yeah, so we will cover these thing as we progress. So these are some core concepts. So here we have finished off with the basic commands in this particular chapter. In the next chapter, we are going to study about how we can create networks. Okay, what are networks in Docker, and we'll also understand about the volumes as well. Okay, so now we are going to talk about Docker networks, and we'll understand what is Docker network and why is it required. So let us take a simple example, simple use case where we have a Postgres database and we want to connect that Postgres database to a PG admin. So PG admin is a database management tool, a web-based management tool, basically where you can like visit some website and you can view all the databases, view all the records, make some anonymous SQL queries and fetch data. So in order to do this, firstly you have to run your Postgres database on a Docker. Okay, you have to expose some ports. Then you will pull image of this PG admin and you have to run this also in a separate container. Now the challenging part here is that since containers are isolated environments, how would PG admin know that in which container my Postgres database is running? Okay, that is something we have to see. Like this is where the Docker networks comes in. So when we create a Docker network, we tell that okay, the Postgres database container and the PG admin container both are running on a single network, and whatever connection PG admin and Postgres has to do, they can do that on that common network. Okay, that is the whole idea. But before that, let us set up Postgres PG admin without creating a network and see what error we get. Is it even possible to connect these two or not? What is happening? And once we use a common network, we will see how that is coming or how that is working out of the box. Okay, given that said, I have to pull images. So if I go to images, I already have two images of Postgres and I have already pulled D page pgadmin 4. Okay, I have already pulled. You can search for pgadmin 4 and you can run this command to pull the image. Okay, once this is done, we have to run instances of Postgres and we have to run instances of pgadmin. Earlier, in the starting of the video, if you remember, when I try to start the Postgres server, it threw me some errors. Okay, it threw me some errors. So I'll tell you what the error was and how exactly did we fix it. So let me remove this command for now. Okay, and or maybe 1 second. I'll show you Docker images. Okay, so these are the images installed. I have pgadmin, I have Postgres. Now I have to run my Postgres. Okay, so this is my Postgres. Okay, so I'll say, let me zoom this. I don't know if it is visible or not. So I'll say docker run detached. The port is 5432. So my host's machine 5432 will be mapped to containers 5432. 5432 is the port on which Postgres runs. Okay. Then -e means environment variables. Okay. So -e key equals to value. -e Postgres password equals to password. -e Postgres user equals to user, and -e Postgres DB equals to do. This is a database we are creating, and now we supply the image. So I am using this. Ideally, both are having the same ID. Okay, just that the tag is different. So I am giving this image ID, and it will run one of the Postgres over here. Okay, so let me run this. And if I do docker ps, you can see I have the container running and my 5432 is mapped. Okay, so we have the Postgres container running. Now let us start the pgadmin container. So let me pull up the pgadmin. So again, docker run minus detached mode port, map my 5050 to containers 8080. Okay, and why this is required? So you can ideally say 80 is to 80. You can map your 80 port as well, but you can give any port you want. So I have just given 5050. And -e pg admin default email admin@admin.com, and -e pg admin default password admin, and the pg admin image id. Okay, let's run this. Okay, now we have two containers running. Let us go to containers. So we have two containers running. One is pg admin, one is Postgres. Fine. Let me walk you through again. So Postgres, so each Postgres has a user ID and password. Okay. So if you want to connect to your database, you generate a Postgres URL. Okay, something like that, and you have to give your username and password. So I have kept username as user, password as password. Very easy to guess, but it can be anything you want. Okay, there is no hard and fast rule on these password, but make sure Postgres password is spelled right like this, because this is a environment key. Okay, and we have to make it like that. So once we have Postgres password, Postgres user, and we create a default database to do. Okay, now over here we are doing the same with pgadmin. Pgadmin email, login email password is set over here. Default email is admin@admin.com. Password is admin, and we give the image name. Now if I head over to localhost 5050, okay, I can see this web-based pgadmin URL. Why 5050? Because we have already mapped 5050 over here. 5050 is to 80. Okay, this is internally, this 5050 of my host machine is pointing to 8080 of the Docker container. Now over here the email password is same, admin@admin.com. Password is admin. So admin admin. Let us log in. And if it is not loading for you at the same time, try refreshing it, it will load. Now over here, if I expand the server, I don't see any server. So if I go to register server, my DB server, it can be any name. Go to connection. Okay, and here add the username password of your database. So my database password is I'll tell you what this is, a Docker YAML. This is just for reference for now. So my password was or maybe if don't get confused, so this is what I mean to say, the DB password. So user is user, password is password. So it is user, and this is password, and here you can give Postgres maintenance database, that is fine. In the connection, let's try giving local host. Okay, localhost 5432. How it is coming? 5432. This 5432 5432. Now let us start establishing connection. It says unable to connect. This, and it is not accepting TCP/IP connections. Okay. Now if I try doing Docker PS, I have the name of the DB as Quirky Heisenberg. Okay, so let me try giving this Quirky Heisenberg as well. Save this. It will see unable to connect to server. Okay, so this is the limitation over here, that we are unable to connect our PG admin to the database. Now to solve this issue, what we have to do is, firstly, let us stop all the containers. So I will select this, delete. Okay. And what we have to do is, this is pgadmin, this is Postgres. This is the same Postgres command, docker run detached port 5432 5432, environment variable password, username user, db to do, and --net db network. Okay, this db network is your own network which we have to deploy our containers on. Okay, but before doing that, you have to run this command, docker network ls. Right now you will see bridge host none and you will not see DB network. This DB network I have created beforehand. That is why it is visible over here. So to create the network, you have to hit this command, docker network create db network. So if you hit enter, it will give me an error. That is obvious because that db network already exists. So you have to run this command, docker network create your network name. Once the network is created, you have to run docker network ls. Once you see, you will see your db network present over here. Once we have created the networks, you have to hit the same command, docker run detached mode, port 5432 environment, password equals to password, user equals to user, db equals to do, hyphen net, and the name of the network, which is db network, and then you give the image name. You have to then hit enter. This will run the image. Now we have to do the same for pgadmin. So docker run detached -p 50 is to 80 environment variable, email admin at the admin.com, default password admin, hyphen net, db network, and image id. You save this, and we have this also over here. Now what we have to do is, if you go to your containers, you will see two containers are running over here. If you now go to 50 50 80, okay, give admin at the rate admin.com and password as admin. Okay, in the servers you will not see anything. Then you go to register server, server name, for example. In the connection, now in the connection we have to give the name of the container. So this was a name of the container, upbeat something. So let's copy this, paste this. No, it didn't copy. So we have given the name, we have given the port, maintenance database Postgres, username, user, password was password, and we click save, and it got connected automatically. Now in the server name, go to databases, you can see our to-do database present over here. Okay, so this is what the networks do. So because of the network, the pgadmin and the Postgres database were able to connect with each other. So this was the importance of the networks. Now in the next chapter, we will talk about volumes. Okay, like why volumes are needed, what happens to the persistence, that we will cover in the next chapter. Um okay, so in this chapter, we are going to understand Docker volumes and what is their significance. So what you're going to do is, I have prepared a small Next.js application. I'll attach the link of this app in the description of the video. You can check this out. So the app is fairly very simple. If you look at the UI, if I have it running, so there's a form, there's a button. The moment you enter something and hit submit, you have a new item in a to-do list. Okay, that's all it is doing. And we are using Next.js. We have Postgres SQL, Prisma, and in the env, I am giving the URL of the Postgres database. So Postgres SQL, user password localhost 5432, and the to-do database which we are going to access. And the schema is something like this. We have a to-do model inside which we have a ID and a content. So this is not a Next.js tutorial. Probably you don't need my help in setting up this Next.js project. We have done it couple of not couple of time, more than couple of time throughout many videos. So I'll skip that part so that this video is only focused on Docker and not it becomes a Next.js video. Coming back to the point, I wanted to show you that if we do not persist the data of the Docker, container, then what would happen and what are the demerits that you are going to face. So imagine that you are working in a company. Okay, they give you this application and you are expected to install Postgres. Okay, that's fine. So for the first day, you set up everything. You started working on the application, and since there was empty, the database is on your local, so data it is currently empty. So you went ahead, created some users, created some mock data, and you did your work for the today, and the next day you come back, you switch on your laptop, and you saw that whoosh, the data is vanished. How would you feel? So would you go ahead, go again, add users, add those data for an hour and start working? Will it be a day-to-day activity of yours? No, right? This is certainly not what we want. And to fix this, we have a data persistency known as Docker volumes. So let me show you the problem first. Let me recreate that problem and then jump to the solution. So what I'll do is, let me kill the server first. And over here, you can see that we have the images. We don't have any container running over here. And there is a volumes section as well, which might be empty for you because you have not worked with Docker before. If you have worked with Docker, and then you might see some volumes created for you. But ignore if it is empty. No worries on that part. Okay, you can create volume from here as well, but we'll see how we can do this via terminals. So let me recreate the problem first. I'll go ahead to my terminal. I hope it is clear to you all. And I'll create two containers. The first container would be for the Postgres database, and the second container would be for the PG admin. PG admin ideally has no role over here, but I just want to show you that, like, when we query the data, I just want to show you that the columns are empty. Okay. So let me fetch the thing for you first. So this is the command that we are going to use. Let me clear this a little. So we are going back to the same commands: Docker run, detach mode, port 5432 environment, password, user, db to do, network, db network, and the image. So if I run this, this will start a Postgres container for me over here, and ideally no volume should be. Okay, there is a volume in use, but I think this is not what we want. Okay, so I think it attach by default attaches a volume for us to use, but I think it reflushes these volumes every time a container is created. Anyways, coming back to the point, so we have container running on 5432. That's fine. Then we create a 5050 80 this thing PG admin container. So this is Docker run detached mode, port 5080 505080, email, password, and the netdb db network. So this is the same db network which we did before. Let me create this, and let me head over to this part, refresh, reload. Yeah, it is it will say it is not running, but it is running actually. Okay, what's the problem? Maybe do it like this. Okay, it creates issues sometime. So yeah, we are over here, admin. We head over to admin. We log in. Okay, and we are here. Okay, so we stop here. I want to start my application. So firstly, since it is a new database, I have to perform migrations. So this is the command. I hope it is visible. So npx prisma migrate dev init. So initial migrations are going to happen, and I migrated my all the schemas to the database now. Now if I go ahead and register a server, some blah blah server, and what is the name of this container? This is the name. I paste it. Post that is fine. User, password is admin. Sorry, password is password. Okay, let's save this. Connected. Yeah, okay. And we have database, to do, schemas. we go to tables. We have a to-do table, and here I say view all rows. So nothing is currently present. Okay, it is no data is present over here. Okay, so I head over to my app. Probably I have not started it, so I'll do yarn dev to start my application. We refresh. Okay, and I add some dummy data over here, and let's refresh. We can see that we have two entries. Now if I rerun these commands, you can see that we have two entries in the database. All good, all sorted. Now what you do is you came back and you deleted these containers. Okay, so if you stop these containers, so okay, so if I stop my container like this, okay, the container has stopped, and if I refresh it, it is going to say connection not established with the server, something like that. Okay, yeah, it is saying. Now if I start this again, start these two guys again, I refresh it, my data is here. Okay, my data is present, my data was not lost. But if you delete these containers, okay, and you recreate these containers again, so this is the Postgres container and this is the pg admin container. Okay, now if you refresh the application, it is going to complain that the schema is not present, to do table is not existing. We can verify this also. Let's reload. So admin, oh, what's the problem? Admin, login, okay, servers, register server, some random name, and what is 5432 boring gates. Okay, Postgres 5432 admin is user, password, save, set okay. And if I go to database to do schemas, tables, you see table is empty, no table was created, so which means that our data is lost. So I have to run the migrations again, npx prisma migrate dev, and if I do yarn dev again, and if I restart, I am able to run the application, but the list is empty. Now if I refresh, I got a to-do database, and I can say view all rows empty. Everything was wiped out, nothing is left. But this could have been prevented if we have used volumes in the first place. Okay, so to use volumes, what we do is, what is volume? Volume is something like, it is a persistent storage on your host machine where any application which uses temporary data can put data there. So as you know that Docker is completely virtual. Okay, when we did Docker exec it, we landed into the directory of the Docker. Okay, and there were some files, var lib data, those are temporary files. The moment you destroy the container, that virtual file system is gone. It doesn't exist anymore on your system. Okay, it was all virtual. So instead of keeping data on that virtual file system, what you do is you keep the data on your host machine, so that every time the container comes, instead of looking for data in the virtual file system, it looks out in your host machine. So enough talking, let me show you how this is done. So if you run docker volume ls, you will see list of all the volumes that are present in your system. So you have to create your own volume. So docker volume create pg data 2. For example, I created a new data, and if I do volume ls, I have pg data 2. Initially I had a pg data for myself, now this is pg data 2. Awesome. And you can see this inside your volumes as well, pg data 2. Okay, awesome, we are able to see. Now just clear everything off, and we have to run the commands like this. So this is the command, pretty much same from the previous one. This is for Postgres: Docker run detached port environment network -v. -v stands for volume, and pg data is the volume, pg data 2. Now, okay, this is pg data 2. pg data 2 is the volume which we created, and colon the place where Postgres stores its data in the virtual file system. So -v whole the volume name, colon the destination from where you want to pick the data from the virtual and put it in the host machine, and the image. Now we did this, hit enter. Okay, what it is saying, did we, okay, we did not create, sorry, okay, we have to destroy these containers. So I created this container, and for pgadmin it is same, nothing is changing. So this is pgadmin, nothing is changing for pgadmin. Okay, now again this is a fresh build, fresh data. So again there is nothing present over here, but this time we said that, okay, Postgres, anything you want to store this time, instead of storing in your virtual file system, store in pg data 2, store in this volume. So if you head over to volumes, you can see that pg data 2 is in use. Okay, and you can see this is the big file of it. All right, so this is pg data 2 over here, and we are going to do the same stuff. We are going to perform the migration. Okay, we perform the migration, we run the app, and we come over here and we start the app, and here we are going to store some meaningful data. So I will call this data 1, submit, data 2, submit, and we refresh, we get these two data, and in the pgadmin also we can see it. So let me fetch the data from the servers. Okay, we have to register server, some random name, then containers 5432, Zen Hawking, Postgres, admin should be user. This is repeated irritating step, I know, but we have to do it. Okay, this is done. We go to database, we go to do, schemas, tables. We have to do, right click, view edit data, all rows, and you can see data 1, data 2 is present over here. Alrighty, good for us. Now we are done for the day, and what happened is we accidentally delete this container. Okay, we delete this container, gone. Now what will happen is I will run the command, this thing, docker run detached port environment network pg data 2. Okay, I am saying that this pg data 2 also tells us that if you are creating this new container, you start, if any data is present on pg data 2, fetch it already. Okay, it will start fetching also. So I create this, I create pgadmin. Okay, these containers are up and running, so we will refresh the, okay, it is starting, so it will take some time. We will wait for it. Okay, I think it is running now. Admin, and we have to connect the server. So what is the name this time? By the way, we could have used container name, so that might have helped us. But anyways, user, password, save. Okay, now if I open the database, go to do, open schemas, open the table. Oh, to do was already present. Now right click to do, view edit all rows, and data1, data2 was fetched this time, and we did not lose the data. And remember, I did not kill the server of my Next.js application also. So if I refresh, you see data1, data2 is still there, and it was not gone. So this is the power, this is the importance of persisting data, Docker volumes, and this is how we store data. So this was all in this particular chapter. I'll see you guys in the next one. All right. So welcome to another chapter, and let's do a quick recap of what things we have done. So we have covered the requirement of Docker, like why it was required, and we discussed the difference between images and containers, and how an image is made up of multiple layers, and how Docker is different from a virtualization machine. And we discussed what are the different layers of a operating system. Then we did a port mapping, and we understood how we can use various versions of Redis and map them to different ports on the host machine. Then we also discussed a lot of commands related to Docker, and we went inside into the depth of understanding those commands. Then we also understood the volumes, or as to why the volumes are created, how the data is persistent, and what exactly happens when the data is not persistent and it is lost. So to save us from the troubles, we did the volumes. And now finally we are at the part of understanding the Docker Compose, Docker YAML files. Okay, so what exactly is a Docker YAML file? Why do we need it? So it's pretty straightforward that every time you are not going to run these commands. Okay, so like this is a hefty command for us to set up a container, and you if you are setting up the project, you may know what specifications you have to run to set up the container for this particular project. But imagine if you are handing over this project to some of your colleagues or some interns, they do not know, okay, so I have to run this command, this is a port, this is a password, this is a network, this is the volume that I have to attach to. So these are the various stuff that not other people know. So to let other people know, to make their life easy, we have a Docker YAML file. Okay, it is just a YAML file. You can rename it as anything, maybe my name like jscafe dot YAML or whatsoever you may want. It is just a YAML file, and in this YAML file you provide every configuration that we did on the terminal. So this is just a replication of the Docker run command inside a YAML file, so that you don't have to write that command again and again. This is as simple as that. So if we compare, if I want to set up a Docker for my project, I'll create a Docker YAML file, and I'll tell, okay, which images which I have to use for this particular project, and what are their configurations. So first of all, you have to start with the version. Okay, what is the latest version of the Docker? So it is 3.9. Then you have in the services, you have to give all the services, meaning all the images that you want to use. And this is the service name. So services, service name, image. So this service name is nothing other than container name. So this is a container name over here. And if I show you, okay, I don't have it running, I'll show you in a moment. So this is the container name, this is the image. If you go over to images, so this is the Postgres image, this is the DB page pgadmin4, this is pgadmin4. So you give the image name, then inside ports you do the port mapping, host colon virtual host. Then environment is all the environment variables. Let me also do the mapping side by side. Okay, so this is for the Postgres. Yeah, so Docker run detached -p 5432. This is port -env. So we have Postgres password, Postgres user, Postgres DB, Then we have volumes, pgdata2, varlib postgres SQL data. This is the place where the Postgres stores its data. Then another service we want to use is pgadmin container. So this name can be anything. You can give any name you want. Okay, there is no rule over that. You can give any name over here. Then you have image. Then it depends upon Postgres container. What it will do is, I think it will execute the images sequentially. So if this pgadmin is dependent upon Postgres container, this is the name, then this will not run until unless the Postgres is set up. Okay, let us verify this once. But if not, it is not required also. Okay, you can skip this. Then we have port 5050/80, environment variables, and over here you define the nature of the volumes of the Docker. So this is pgdata2, this is external2. I will tell you what this does, external data2, what is done and what is the alternative. So if you do something like driver local, okay, like this, so it will create a fresh volume for you. Okay, so I will tell you what it is. So to run the Docker command, to run a Docker file, you have to do docker compose -f, matlab meaning that you are giving it a file, then you give your file name and then up. Make sure that you are inside this project itself. Inside, for example, this is Docker Next.js, so I am inside my Docker Next.js folder and I run this command. The moment I run this, okay, you can see it is running Postgres container 1. Okay, yeah, so this, see, it is happening sequentially. So first the Postgres was set up, then the pgadmin was set up. Okay, so these are happening in sequence. Now if you check your container, you will see Docker Next.js. Okay, it is a stacked containers. If you open this, inside this you will see two containers are running. One is Postgres container 1, another is pgadmin container 1. Okay, here you give the image, these are the images, this is the port, and it is saying that two containers are running over here. And if you go to volumes, you can see that a new volume was created, Docker Next.js pgdata2, and it did not use our existing pgdata2 volume. So what will happen over here is, since this is a fresh volume, so it will not have all the migrations and it will give you error. Okay, so in order to use the external volumes, okay, so this is what driver was doing. It was creating a local volume for this Docker itself, okay, for this project only. If we want to use the external volumes that are created by us, then in that case, what you have to do is, first of all, go to containers, delete these containers. Now come back and change this back to external true. What this will do is, it will now, we will now run the command again to run the Docker file. And let us wait. Okay, now PG container is also there. Now if I run my application, I will see all the data present already, data 1, data 2. And if you go back to images, to volumes, now you can see that Docker Next.js pgdata2 is not used, but instead our pgdata2, this one was used. Okay, and this one is for, I think, pgadmin. Okay, this one is for pgadmin, this is for Postgres. Okay, so this is how we do Docker compose. And see, this has become now very simple. Okay, I just have to push Docker YAML file into the GitHub repository. I will pull this project, and to run the application, I just have to run the Docker compose command and everything will be set up. So what I am doing, I am running the server, the dev server over here using yarn dev, and another Docker compose command to Dockerize Postgres and pgadmin 4 for the database. So as a developer, my life has become very easy that I don't have to now set up this thing, Postgres, then I don't have to set up PG admin, a user ID, password, anything, nothing like that. Okay, I just have to worry about setting up the project. Then everything related to database, caching, Redis can be handled by Docker, and it will be handled from there. I don't have to worry about doing this from scratch. Okay, now be it my Windows machine, be it my Ubuntu machine, be it my Mac machine, I don't have to worry about setting up any of these packages on my machine, and I don't have to worry about the configurations, okay, and the versions. All this is handled by Docker, and this is why the developer experience is enhanced when you Dockerize your applications. Okay, rarely I have to do any changes to Postgres, because since this is a front-end project and I have to don't make any much changes. But if you want, you can do backend changes also, you can do PG admin changes also. It is up to you, but this is all local. Okay, you don't have you are not dependent upon anyone. So this was simple Docker Compose. Okay, this was a Docker Compose thing. And next thing which is left is creating images. Okay, so we can create an image of Docker Next.js and push it to a private or public repository. Once that is done, I will show you how we can deploy the image created over some server. I will just mimic some data. Okay, I will just mimic whatever is being done over here, but this was all in this particular chapter, and I'll see you guys in the next one. Hi, welcome to another chapter, and here we are going to understand how we can create images. Creating images is a really very simple, just that if you know the basic concepts, you can easily create any image of your application. What exactly we are going to do is, so have you ever wondered how someone was able to create an image of Redis, or if you search for Node.js or Postgres or pgadmin4, these are all the packages of the images which we have used before, but someone would have actually created it. So how exactly we can do this is what we are going to understand in this particular lecture today. So let's get started. Things are really very easy. Okay, so our aim is to so since we have this repository, Next.js application called Docker Next.js, my agenda is to Dockerize this application, okay, so that no one else has to set up this repository from scratch. Or the overall main agenda is that using that image, someone can deploy this onto a production server using the Docker image. Okay, so I don't want anyone to log in into CLI, do git pull origin master, then run yarn again every time. No, this has to be automated every time, and doing this is very easy when we do have Docker in the place. All we have to do is to place a Docker YAML file on the server, and we just have to run the Docker YAML commands, and all the images would be up and running. But that is the second half of the chapter, or it is the next chapter itself, because it is quite complex. It involves ECR and other stuff. But to keep things simple, let us only focus on creating an image of this project, Docker Next.js. Just the Docker Next.js project only. We are not incorporating Postgres or pgadmin in this image. This image is purely of the Next.js only, because Next.js is composed of JavaScript code only. Postgres, SQL, pgadmin4, they were pulled from a separate image and not part of this particular repository. Okay, you have to make sure. So what we will do, we will be only able to Dockerize this application, and somehow in later point of time, we are able to club Postgres, pgadmin4 and this application together inside a single Docker YAML file. Okay, that is the whole agenda. All right, enough talking. So what we have to do is we have to create, okay, if you go to the root of your application, you have to create a Dockerfile. Okay, this is a case sensitive file name, so make sure that it is spelled correctly with D as capital. And once you do that, you will see a Docker icon next to the file, and inside this you have to place this 7 line of codes. Very easy. So as already discussed, that images are made up of multiple layers. We have a Scratch layer, we have a Alpine Linux layer, and on top of that we have a node layer. When we say from node, it means that we want to create a image from the node image layer, and over top of the node layer I want to keep a layer of my application. So we have a Scratch, we have Alpine, we have Node, and on top of Node, what we have a Docker Next.js. Simple as that. Now we created a directory. Okay, this is a Linux command. So run make directory home/app. Okay, run is a command which is used to execute commands while creating a image of this application. Okay, so these are all commands provided by Docker. So from is to specify from, you have to set the base image. Now run execute any commands on top of the current image as a new layer commits. Okay, then I am setting the working directory. Okay, so what now moving forwards, whatever commands I run, they will be happening inside home/app. Okay, and I say that whatever is present over here, dot copy this inside the newly created app. So we have a separate folder of app where we are keeping everything. Okay, and I will exec into this directory and show you where exactly our code is placed. So once we copy it, we run the yarn command and we expose this to 3000. Okay, so why 3000? Because once we have the image, this local image has to be exposed to the host machine so that someone can access it. Okay, so we exposed a 3000 port, and cmd command is the command to execute or start, or is the entry point of your application. Okay, so running this command, any image can be turned into a container. Okay, this command will be running when someone clicks on the play button. So if we have this play button over here, so what it does is it executes this command only, nothing else. Okay, I hope that this whole sequence is understood. And you could place this above, 5 above as well, 4 below as well, it's your choice, but this will work as well, no doubts. Okay, now we have created this Docker file. This will help us create this image, but we do not want to keep node modules. Okay, I do not want to keep Docker ignore or Dockerfile. So we have a Docker ignore file. Okay, this Docker ignore file helps us keep track of files which we do not want to push into the images. So okay, I do not want to push node modules. I don't want to push the Docker ignore itself. I also don't want to push the Docker file. Okay, so these are the things that if you have any more files, any more assets which is irrelevant to the image, you can place them over here. You have to do dot Docker ignore and you can place all the files. Likewise, we can also put dot next here as well. Okay, because this is a cached folder. Okay, it creates cache of it. So I don't think it is required. We can put dot next as well. You can try it out. So once you are done with this, okay, you have to execute this command, which is docker build dot -t and your image name and a version. Okay, so dot means what? That this Docker file is present in this current directory only, which is Docker Next.js. Then we have -t and then followed by Docker Next this. Once you hit this, it will start creating the image. You can see that it is running yarn command. And let us quickly skip to the next part. Okay, once you do this, you will see all these steps getting executed like this. Okay, this is the exact sequence. And once you do this, you can come to your Docker desktop, and in the images you can see this Docker Next, which is taking 3.31 GB, and this is our image. Okay, we have created this image. This is present on local. Okay, this is not present on Docker Hub. This is not present on Amazon ECR. Okay, we are going to do that in a moment, but this is what it is. Now, once we have created this image, you have to go to your env file, and earlier here it used to be localhost. Instead of localhost, you have to change it to Postgres container. Okay. Once you do this, you are fine. Now, I have a quick brainstorming session for you. Why did we need to put this like this? Can anyone guess? Like, take a minute or two, think about it. If you have followed the tutorial religiously, then you might know the answer. Why do I doing this? So the next part which we are doing after creating the image is to run the application, the Postgres and the pgadmin pool collectively inside a Docker compose. Okay. This you will not do locally. Okay. Why you will do this locally? Because the whatever code changes you do will not be affected immediately on this image. Okay. Whatever code changes you do will not be affected in this image. If somehow your code, you do code changes and the image automatically get what we say, hot reloaded, something like that, then it makes sense. But right now it is a static image. So where exactly do we do this whole arrangement? Where exactly do we put app, Postgres and pgadmin container together so that they could be run? Yes, they could be done on a production environment. Imagine you are the owner of Vercel, and every time someone pushes a code, you generate a new image, and on your server you update this image and run a Docker compose file to run the application. Okay, this is making sense. I hope you are getting to understand, because you don't really have to worry about what this application is doing, what is the run command. It is all handled by Docker itself. So once you create the image and once you want to deploy this onto a server somewhere, maybe if you are a Vercel owner, then behind the scenes you are doing this, or maybe you have a pipelines set up with Jenkins doing automatically all this stuff, okay, for you. But I'm showing you how these softwares behind the scenes do stuff. Okay, so imagine your system is a production environment. It is a production server. Sorry, it is a production server where you are pulling code changes from everyone, and you have to make sure your dev.jscafe.dev is running, or the staging environment is up to the latest changes. How do you make sure? So imagine this machine is my staging environment. I want to pull up everything, the code someone has given. So Jenkins has imagine Jenkins has recently created this image of the entire code base of your project. This is from a branch cut. Okay, from a branch cut happened yesterday, and this is the code that is going to be pushed to production. Okay, so Jenkins has created this image for you. Now you have to run a command to deploy this image on the production. So how we are going to do this? We are going to automate stuff, obviously. So something like that, what it will do behind the scenes is it will grab the ID of this image. Okay, it will grab the ID of this image, and it will come, it will have a separate Docker YAML file. Okay, this is not the Docker YAML file from the Docker NX.js. Okay, imagine I am going into like I am going into this PC. Okay, then in C drive I put one Docker file over here. Okay, then I ran this command. I come over here and say Docker compose something. Okay, so this, do not get confused that I am making change. Although I am making changes in the same Docker YAML file, just to not write it again and again. But imagine that this Docker file is existing out of this repository somewhere on a production environment. A fresh EC2 instance is created by someone, and they have just one Docker YAML file. That's it, nothing else. Okay. That is the agenda. Think in that ways. So on my production environment, I have newly created a Docker YAML file, and inside this Postgres container, PG container is same from the previous chapters. This is from Docker Compose. The only thing I have added is a app. Is a app service which depends upon the Postgres container. So after we have Postgres container and PG admin running, we will start our application, and whatever we have just copied from over here, I will paste the image like this, because this is a local image. Okay, and I am exposing port 3000 so that anyone who comes to my EC2 machine is able to access it. Simple. Now once this is done, you can see that my application is currently not running, and if I go to localhost 3000, it will say server not found or something. Okay, now what I will do is I will run this docker compose command on my EC2 instance. This is my EC2 instance. Docker compose -f docker YAML.up. I hit enter, and you can see first the Postgres container ran, then app also ran, and I think sometime PG admin container will also run. Okay, now if I run this command, reload the page again, I am able to see my software running. I can do blah blah blah, submit, refresh. Okay, I can see my application running on prod. Although this is local, but whatever we did stuff over here, imagining EC2 instance and other stuff happening on prod. This is a prod production environment. So this is exactly what happens in big companies. There is no some guy sitting 24/7 just to pull the latest master branch and CD into your application, do yarn install, yarn dev again, and then redeploy. No, this is not happening. This all is happening via Docker only. Okay, that is how what the scale of this Docker is. Eventually we'll see how Kubernetes and other guys play into the role, but we have not covered Kubernetes. Yes, right. So I'm showing that how, if at all, if a company is using Docker, how would they deploy their CI/CD pipelines and other stuffs like this. Okay, so what we did, let's do a quick recap. That this terminal, imagine this is your EC2 terminal, and forget everything of this code. Nothing is here. We just have one Docker YAML file on the server, and somehow someone, Jenkins over here, like a disclaimer that Jenkins gave me the image. Okay, this is the image. I just updated this image over here, and I just have to rerun the docker compose command, and my production environment will be refreshed. Easy peasy. Okay, so this is how we do creating images, putting on the production environment, and so on. Now comes the Amazon ECR. Okay, Amazon ECR. We did everything locally. Okay, this is all locally. Now comes Amazon ECR. We will cover this in the next chapter. I'll see you guys there. Hi, welcome to another chapter of this series. And here we are going to deal with Amazon ECR, Amazon Elastic Container Registry. This is for managing Docker containers. Okay, so first thing first, what exactly is this? So there are two ways, as discussed before. One is public repository, like Docker Hub, where you publicly expose your image to the outer world. Or if you are some organization or company, you want to restrict this image to be accessible only to your employees. Okay, so to do that, we have ECR. Docker Hub is really very easy. Other content creators have already covered it so many times. So I thought why not talk about the part which is going to help you in your company. So we are going to talk about Amazon ECR. And ECR, it is again a feature provided by Amazon AWS. And here, this Amazon ECR manages the repositories. You can create a repository and push images inside that repository. May it have multiple versions and tags. So what are the steps? Firstly, you need to have a Amazon AWS account. Be registered, add your credit cards, and sign up. Once you are done with this, you have to make sure that if you are on Windows machine, Linux, or Mac OS, you have to have AWS CLI installed on your system. You can just Google install, you can go through this particular link as well, which tells us how to install or update the latest version of AWS CLI. And if you are on Windows, you can go ahead and click this. It will download the CLI installer for you. And that's it. That's all you have to do. Once you run AWS version command, let me grab this and run this over, show this as well. So you can see that I have a Amazon CLI installed already on my system. So these are the basic prerequisites that you have to do before beginning with this section of this video. All right. So once you have Amazon, this, we have to create a user for your accessibility. So you have to grant a user certain access to access your repository. And that is why we are going to create a user for us. I know you will be able to see the access key and other stuffs, but don't play smart. I am going to delete this user after the video is created, so it will not exist anymore. So I'll say ECR2 and hit next. Then you can click on attach policy. Here you can search for registry, and you can click the first one, and Amazon Elastic Container Registry public full access. Hit next. These are the things. Create user. So this is ECR2. Hit down, go to security credentials and create an access key. And this is for command line interface. I understand. Did not read though. And I don't think this is needed. And we have a access key and a secret key. All right, awesome. And what we have to do is you have to go to terminal, type AWS configure, hit enter, grab your access key, hit enter, grab your secret access key, hit enter. Default region is, you can get it from over here, which is EU North 1. Yeah, it is already saying. So EU North 1 format, JSON, hit enter, and that's it. You have set up the authentication of the user. You have CLI. You are already having a AWS account. Then you have to go to Amazon ECR. You'll see empty, just like this. We don't have anything. Create repository, and let us call this docker/next.js, and just create it. This is as simple as it looks. Then we can go inside it, and we have no images. This is something similar to this list of images. Over here it is empty, so we have to push one image onto this cloud repository. So click on this button, view push commands, and you have this guy over here. Just copy this, and you can come over here on your terminal, clear everything, paste it, and let's see what it has. So it says Amazon AWS ECR, get login password, region EU North, Docker login username, AWS password, and over here this is the repository. Okay, this is a repository. This is just for the authentication. So let's do this, and it failed miserably. The term AWS is not recognized. Okay, maybe my bad. Let's hit this over here. It should run. It should say logged in. Yep. So it say login succeeded. It did not work over here because maybe the environment is not being bubbled up to this VS Code terminal. Maybe I have to restart my system to do this, but it should work ideally. But anyways, And from the previous video chapter, actually, this is the command. This is our Docker file, which is going to help us create the application image. So let's head over, and here we have build your Docker image. So Docker build -t, and this is the image name, and this is the dot over here. So I just paste this over here. It is going to build it. It's gonna take some time. Let it take it time. We are going to fast forward. All right. So the build step is done, and we have to tag our Docker image. So Docker tag next.js latest, and this is the repository. Okay. You can keep it latest. You can give 1.0, 1.1, depending upon your case. I'll just keep it latest. And Docker push command is over here, and just hit enter. And this will be pushed. Okay. So it is pushing, I think, layer by layer. So we will just fast forward. Awesome. So this is pushed. And now if you close this, and is there a refresh? Yeah, we have a refresh button, and our image should be visible over here. Okay. Now this image is, so what happened is that if you imagine in terms what might be happening behind the scenes on actual companies, so so once you push your changes on a branch, Jenkins, what it does is it creates an image and pushes up to a Amazon ECR. Okay, so this step we did manually to replicate how exactly it is done behind the scenes. Once you have the image, you can copy the URI. Okay, and imagine once you have the URI, you have to pull this image on the production server. So we are going to do the same steps that we did before. Okay, so this is the URI. We have to paste the URI over here. Okay, on a Docker file, Docker YAML file. This Docker YAML file is present where? On a production environment, somewhere sitting idly. There is no code, just a YAML file. So it receives the updated URI. It changes the URI of this app over here, and what it does is it runs the Docker compose command again. So this is Docker compose -f Docker YAML up. It hits, and it starts fetching from the private repository. Since we are already logged in on the Amazon account, so we are able to see this. Now if I refresh, the app is getting compiled. Now you can see that my app was compiled. I was able to write new stuffs, submit it, refresh, and everything is working fine. Imagine this is your production environment. So this was how we deploy stuffs, create image using private repositories on Amazon ECR. Really very easy peasy, piece of a cake. So nothing hard. And next we are going to cover is cal.com repository as well, where we'll see how they utilize it effectively for open source. Okay, so I'll see you guys in next subchapter. So hi, welcome to another chapter, and here we are going to talk about the importance of Docker in open source. So if you have heard of cal.com, so cal.com is, a scheduling platform where you can schedule meetings, and it has a bunch of stuffs as well. You can check out cal.com and see what exactly they have, like from app integrations to meetings to conducting live sessions and other stuffs. But this is a totally open source, and you can visit the cal.com repository over here. This is a single repository, and over here they have utilized Docker for everyone who wants to contribute to this cal.com repository. All they have to do is follow these steps. Firstly, you have to clone this cdcal.com yarn, install this, and set up the environment file. Once that is done, you just have to run one yarn dx command, and out of the blue, thing will run and you can see your application. So I have cal.com set up locally. I have done all the steps that were told to me, and I am inside the cal.com repository. All I have to do is run yarn dx, and it will initiate Docker compose over a turbo repo. And you can see this if you are familiar with these terminals. These are various containers that are running of Docker, and these are the logs. So I think it is generating a bunch of stuffs. And once this is done, you would be able to actually set up everything locally without have to worry about what node version, Redis, DB it uses, and it just do out of the blue everything for you. And that is how any open source repository should be, that your contributor don't have to worry about how do I set up XYZ stuff before starting to even contributing. Imagine someone taking a day just to set up your open source repo, and they'll start contributing from the second day. So this is by the time all of the motivation might be gone, and no one actually feels very motivated if you have a very destructured and very bad developer experience. So what these guys did was something incredible, and you can see that that is the reason why this is actively one of the highly actively contributed repo. It has over 7.3k folks and 157 watches and 30k stars. So they have done a splendid work, definitely, and they have bug bounties and other stuffs. So this is it, and I think if I hit localhost 3000, I might be able to run the app. It is compiling. Okay, let's just wait for it to compile. Okay, so it has compiled the middleware. It is compiling auth/login. What else is left? Okay, it has fetched some env vars, and import is it is compiling. So you can see that I was able to run the cal.com on my machine. And I think I have also merged one PR before as well. If I go to pull requests that were closed, and yeah, this was the PR. I think, yep, this was the PR that got merged in cal.com. And all thanks to Docker for the easy setup. I was able to get onboarded in no time. This was, I think, a very easy fix, and PR Rich also approved the changes. But yeah, that was the gist, that how important Docker is. You see, I just ran one dx command and everything was running locally. So this is the power of Docker, and I hope you understood everything. It was all clear for you, and this was all in this chapter. Thanks.